Hello, our group today will talk about the advances in blockchain security. Our group members are Shang Jianhu, Tiange Wang, Kang Xiangyuan, and Ziyang Zhang. The contents today are: what is blockchain? The basic security features of blockchain technologies, the consensus mechanism, majority attack, and fork problems. Let's start from the question: what is blockchain? The idea of blockchain was firstly introduced in 2008 as the underlying technology of one cryptocurrency, Bitcoin. Narrowly speaking, blockchain is a chain data structure in which data blocks are sequentially connected in a chronological order. Each block contains previous hash value, transaction data, and timestamp. Broadly speaking, blockchain is a new distributed infrastructure construction which contains many technologies like cryptography, mathematics, algorithm, and economic model. Blockchain uses distributed consensus algorithm to solve the traditional distributed database synchronization problem. The blockchain technology is composed of 6 key elements: decentralized, open source, transparent, anonymity, autonomy, and immutable. Next, we will describe the security fundamentals based on the features of blockchain technologies. The basic feature of blockchain is decentralized. It means there's no centralized management organization in blockchain. Data block connects with each other peer-to-peer. The data can be recorded, stored, and updated distributedly. As we know, the risk of centralized system is once the center has been attacked, the data is tampered, the whole system will be broken down. But there is no such possibility for blockchain system collapsing from the center. As a decentralized system, blockchain has high Byzantine fault tolerance. There is also decentralized consensus claimed with a blockchain technology. Blockchain has the features of open source and transparent. Most blockchain systems is open to everyone. Besides private information of counterparties, data could be seen by everyone. Participants could query data information and related development applications through public interface. The whole system is highly transparent. Then, how secure of a blockchain application can be seen directly from the open source codes and the algorithms used. The features of blockchain technologies may bring users with more reliable and convenient services. Blockchain also has anonymity feature. Data transfer among nodes complies with negotiated algorithm, and both parties of transaction only need to know the blockchain address of the other side. There is no need to know the private information of the parties in the transaction to gain trust. Thus, the privacy can be protected more securely. Blockchain is also autonomous. Blockchain uses consensus-based specification and protocols so that each node could transfer data with other node freely and securely in a trusted environment. Any human intervention does not work, and blockchain security is achieved. Finally, we should say blockchain is immutable. All the data needs to be validated first, and then it could be stored in the data block. Once the data has been stored, it will be reserved forever. The temper of the single node makes no sense to the whole system, because all other nodes would check the validation of data so that invalid node will be abandoned. Unless the attacker could control over 51% nodes in the blockchain, it is possible for the attacker to alter the data stored in each block. Consensus mechanism is one of the most important mechanisms in blockchain technology. It is a protocol which makes all blockchain nodes have agreement in the same message and ensures that the latest block to be added to the blockchain correctly. The most frequently used consensus methods are proof of work and proof of stake. Proof of work is a requirement to define an expensive computer calculation, also called mining. Proof of stake: the creator of a new block is chosen in a deterministic way, depending on its wealth, also defined as stake. Proof of work means system will raise a problem which is difficult to solve but easy to verify. The calculation of proof of work is called mining. Each miner tries their best to find the solution. Once one miner computes all the works, it will gain the right to record the next transaction in the blockchain. The difficulty of solving proof of work is limited to the rate of one new block generating about every 10 minutes. The advantage of proof of work is the algorithm is simple to verify but hard to break. But the disadvantage is that large energy consumption and much time used. Proof of stake: miners who own more cryptocurrencies have higher probabilities to obtain the next right to record the transactions. Unlike proof of work, proof of stake greatly reduces the amount of computation, therefore increasing the throughput of the entire blockchain system. However, proof of stake will increase the wealth gap in the blockchain system. There are some challenges of blockchain technologies. One of it is the majority attack, also called 51% attacks. As we know, blockchain relies on the consensus mechanism to establish mutual trust. However, the consensus mechanism itself, especially proof of work-based blockchain, has 51% vulnerability. If the attacker obtains more than 50% of the computing power in the blockchain, then it is possible for him to generate a longer blockchain than the current existing blockchain. If success, attacker could arbitrarily tamper the data stored in the system. However, due to more and more miners participate in the blockchain, the consumption power also grows significantly. In practice, it is very hard to control over 50% of the nodes in the blockchain. Furthermore, the cost of mastering 51% of the computing power is very huge. It's not profitable for attacker to launch an 51% attack. The last thing we will talk is also a security challenge of blockchain technology, a fork problem. Fork problem is related to decentralized node version. Some nodes may have been successfully upgraded, but others not. A fork occurs when disagreement arises between old nodes and new nodes. One is called hard fork. The old node couldn't agree with the mining of new node, so one chain becomes two chains. When hard fork happens, the old nodes cannot work as usual until they are all upgraded. Another fork is called soft fork. In soft fork, new nodes couldn't agree with the mining of old nodes, but they will still continue to work on the same chain. In soft fork, it allows old nodes to improve gradually. It will not affect the stability and effectiveness of the system.